our special guest, the one, the only Mike Chatten. Mike Chatten, if you're not familiar with him, is the guy that would sit in the corner and fix everything that was wrong with the network in the room you were in. Not only would he fix it, but the part that I always forget and don't want to have anything to do with, he actually talks to the hotel people, the IT staff in the hotel, and gets it set up in the first place, which is just, that's a nauseating concept in my mind. So I appreciate his efforts when he's there. And I know when he's not. It is very obvious when there isn't somebody taking control of those things. So please welcome Mike Chatten.
For allowing me to talk. Hopefully this will be a little bit interesting and somebody will get something from it. So let's talk nerdy. Let's advance the slides. So I've broken down just a couple of quick bullet points. We'll go over network topology and a little bit of terms super fast. I know most of the people on here, I know you all are a lot more technology savvy than you let on. So I'll try not to dumb it down too much. We'll talk about some network best practices that everybody can do at home. And my favorite super secret #1 tip that not everybody talks about, and it is actually a huge problem, and probably the single best thing that you can do. A really simple graphic of what a home network looks like. You start off with your connection coming from your internet service provider, going into a modem, whether it's cable, DSL, fiber, bonded telephone connections, and then it goes out from there. However, it's probably one of the last pieces of technology that people really think about as having a really big impact on the workflow. We focus on the latest software, the latest hardware, but especially now with so many people working from home and having a good stable connection being so vital, it's something that everybody really needs to take a step back, revisit, and do a little bit of network triage at the very beginning. So the first point there, how old is your tech? I can tell by the picture that Ed posted that he was using a wireless router that maxed out at 802.11g, which is 3 standards ago and about 6 iterations. So that's why we were seeing that maximum data transfer rate of 140 megs per second. That was the highest theoretically that it's ever going to connect. So if you're rocking old technology like that on your wireless or even your hardwire connection, it's really something that you should think about revisiting. Which leads us into the second point. What kind of flexibility does your current hardware offer? If you're one of those people that just relies on the modem from your ISP, you're going to be extremely limited into some of the later points. And that's going to always act as a bottleneck then on your network. And does it serve your needs? Do you have enough capacity? Do you have enough physical ports? Do you have the wireless range that you need? Do you have the data throughput that you're looking at? And then the last point is, where are things located? This is especially important if you are relying entirely on a wireless infrastructure to get a connection back to your personal machines. The greater the distance, the less throughput, the less speed, the more latency you're going to have with all of those things. So for me personally, a great place to start is right at the modem level, that first point of entry into your house. A lot of times when you sign up for internet service, AT&T, Verizon, whoever it is, drops in a device. It just kind of sits there. I know a lot of people just rely on that to be the head end of the network, which isn't a great practice to have because they're mass producing, they're purchasing in such large volume those devices that it's not the highest quality. They're not really concerned so much about security, performance, and that can be the first bottleneck within your network. So what I always prefer to do and what I've done for many, many years is I don't rely on that to be anything more than just the modem. I just want it to perform the role of taking the signal from the coax, converting it to Ethernet, taking the signal from the fiber, converting it to Ethernet. I don't want it to function as a router, as a firewall, as any other device. I want as clean of a signal as possible to come into a device of my choosing, one that gives me the flexibility that really works within my needs. Additionally, a lot of times those cheap modems are also spitting out wireless signal. So if you have another wireless device beyond that, you're just clogging up the airwaves around your workspace, and it's something that's not needed. So if you can take a lot of hardware and software features away from that and just give it one role to focus on, everything downstream is going to see a much better performance increase. From there, that kind of leaves me into step 2. We're going to skip the router talk for now. Wired. No wires close by, find a way to wire it up. This should be everyone's #1 priority if they are on a wireless only network within their workspace. It's not always going to be easy to do, but we always want to have the cleanest, most stable, least prone to interference or additional latency as possible, especially if you're somebody that's controlling graphics or providing any upstream data. If you're providing a feed up, it is vital that you are on a hardwire. If you're somebody that's just watching as a participant, there's a little bit more flexibility with that, but ideally, hardwire is the way to go. It's most electricians, if you need wires run physically through the wall, most electricians can do that for you. It's generally not that much of a charge. If you're somebody that doesn't need it except for when you're running a show, just invest, buy a really long Ethernet cable, have it snake through the house during the event, unplug it, coil it up, throw it away, throw it in a closet, don't throw it away, and just leave it for when you need it. It really is the best way to go. If you do have to go wireless, or if you prefer to have an expanded wireless network, one consideration to think about is whether you want to have a standalone wireless device built in, meaning built into your router, or if you want to make the investment in an expandable system. One of the great things about having an expandable system is if you do have a larger house, or if you have a greater distance from your wireless router to your workspace, having the flexibility to add additional components easily and seamlessly into one ecosystem enables you to expand your wireless bubble in a much greater range. And another important feature to think about, or consideration to think about, is the actual location of your wireless device. Right now, my wireless device is located kind of in a good central position in our apartment. Where we used to live, that was not the case. It was often to a far, far end. So you would see the quality of service drop off very rapidly. So we had to supplement with an additional wireless access point to make sure that we had good coverage, especially kind of in the middle of where we live. So if you're experiencing that same sort of thing where your connection, your wireless router is just on one end of your home, you may want to look into what you can do to expand that wireless coverage into an additional area. Let's talk a little bit more about wireless, even though I'm a much bigger fan of wired, because nobody can survive without wireless, apparently. Proper setup of your wireless network is key. This is not something that you just want to rely on the default settings, regardless of where you live. Whether you live out in the woods and you are the only wireless traffic in the airwaves, or whether you're in a really dense aggressive area. One of the easiest steps to do is to separate your wireless networks. And you do this by creating one wireless network with a unique name that services just the 2.4 gigahertz spectrum. Things like printers, security cameras, IoT devices like Hue lights, wireless speakers, things like that typically only function in the 2.4 gigahertz spectrum. This was the original, or one of the original wireless standards. It has the advantage that it travels further, it travels through more things, but it has a data capacity that's not as high, and it's a little bit more prone to interference. So I would recommend separating those things out. Within your router, you will still be able to have that communication back and forth between devices. It's just a way of forcing those things to live off on their own. And then the second network would be a 5 gig only network for your laptops, phones, any newer hardware that would support the newer technology. You want to always force it to connect to the fastest wireless network possible and not have it be slowed down by any other devices. One of the drawbacks with 5 gig is the distance decreases, but you have an increased connection reliability and stability, and also an increased data capacity. Next slide, please. Oh, I got a little bit out of order. Okay, never mind. So the first thing that you want to look at is to, with wireless networks, is to manually set your channels. Again, don't rely on the default or have it come up and select channels automatically for you, because it's not necessarily going to make the best choices for you. The way that you can do this most effectively is by utilizing a Wi-Fi analyzer software. There's one that's free called Insider by a company called MetaGeek. They have a free PC version. They also have a Mac beta that's out right now. There's also a great one that's actually my preferred now, which is Wi-Fi Explorer, software like that. You want to find the least utilized channels for both spectrums that you are wanting to do. For channels, for the 2.4 gig range, you're primarily looking for a non-overlapping channel. And there's only 3 that exist for 2.4, and that's channels 1, 6, and 11. We will get into why those channels are important in just a minute. For 5 gigahertz, it gets a little bit more complicated with channel selection. That should be decide how wide of a channel that you want. The channel width on both frequencies, 2.4 and 5 gigahertz, will go back to how much data throughput they can actually handle. So this is what my airspace around my apartment looks like. This is actually a lot better than it used to look like. I think some people moved out of the complex and airspace is a little less crowded. You can see here I am 2G-SL. That is my wireless network here. All of this other stuff, these are all different wireless radios that you see. I can tell right away what some of these are, like here, oops, sorry. Here where it just says Eris, I know that that is a standalone AT&T fiber modem that has built-in wireless capability in it. That's just the brand that they use. I can also tell by the settings, they're spitting out an 80 megahertz channel width on 5 gigahertz band, which is not good. Sorry, I feel like I'm starting to get too nerdy. Am I? No?
Love it.
Okay.
This is great.
So the first one that we will look at is on this side of the screen right here. This is the 2.4 gigahertz band. So this is a little bit of an older technology. If you remember before, I brought up the non-overlapping channels. You can see them highlighted down here, 1, 6, and 11. Those are the 3 channels that you want to stick with within the spectrum, because it's such a narrow band. It's not very wide. So when you start to go into areas like where Hamilton is, you start to kind of cross channels, and that creates adjacent channel interference, which is really, really bad. Essentially what that kind of interference is, picture being in a crowded restaurant and the table next to you starts talking louder, so you talk louder, which makes the table on the other side of you talk louder. And then it just becomes this kind of cascading effect where there's so much noise surrounding you that nobody can hear anything. That is probably the worst aspect of the 2.4 gigahertz spectrum. So this guy right here, he thought he was doing the right thing by picking a number channel that was separate from other people, but he's actually making the connection for himself and for the people around him a little bit worse. I ended up picking channel 11 just because when I set this, that was actually the channel that had the least amount of interference. I'll probably go back, maybe I'll do it to 1, but I'll actually probably still avoid 1 just because this guy Hamilton is still creating a little bit of cross-channel interference or adjacent channel interference. You can also see that this guy right here, Fernandez, 2 gig, he is absolutely doing the right thing by separating out his networks. He has a 2 gig and a 5 gig network, but he is broadcasting in a very wide band. He is broadcasting in a 40 megahertz channel width, which is really unnecessary because at a 2.4 gig speed, there's no reason to do it. Your data throughput that you're going to get is data throughput increase is going to be negligible because you're just introducing a greater chance of interference. You're decreasing your overall range, and you're doing it in an area that already has some known interference. So it's very important to look at that. If you go back over to 5 gig, I did the same sort of thing where I picked a channel that had the least amount of interference. There are more people that are broadcasting at a wider channel width, in the 40 megahertz channel width. And if you see these numbers in blue, these are channels that are part of the dynamic frequency selection range, DFS. You typically want to avoid those if you live close to an airport. I don't live that close to an airport, but I live close enough that I prefer to avoid it because you can pick up interference from radar systems. So if you live close to an airport within a flight path where planes are about to land, I would think about changing that and staying out of this. With 5 gig especially, the 5 gigahertz bandwidth, there is the ability a greater ability to set what is called a channel width. So basically on the hardware level, you can bond groups of channels together. And the advantage of this is you can exponentially increase your potential data throughput given the best case scenarios. So a lot of times when you see, this is the latest 802.11's AC router, it gets 1.7 gigs of throughput. What they are giving you is a best case scenario with a channel bonded in the 160 megahertz width. So it's taking all of these channels here, grouping them together to give you the best, fastest, most data throughput, which is spectacular if you live in an area of very low density Wi-Fi. If we go back to this slide, it's something that I would never do here. You would end up taking up a huge chunk of this airspace. You'd start stepping over people's toes, creating interference, not just for them, but also for yourself. There'd really be no huge advantage to it. If you look up here, again, all of these people are spitting out 80 megahertz channel bandwidths to get that high rate of speed, to get that 1.7 gigs of throughput. The reality is they're not getting that actual amount of data throughput because they're just causing interference with each other. It's not a good practice to do. If you lived in an area that you weren't seeing a ton of other network traffic, wireless networks, absolutely do it. If you have to have that throughput. I don't personally think anybody really has to have that input, that throughput. You also introduce a huge element of interference and a decrease of range. So the more of that spectrum you're taking up, as you make your channels bigger and bigger, you're increasing your data throughput, but you're decreasing the range and the reliability of that signal. So it's something that you need to take a look at and really think about if there's a clear-cut advantage. I personally keep my 5 gig radio just in that 20 meg spectrum. I would rather have a more stable connection with a slightly lower data throughput. But I also am not doing things like making huge file transfers anytime I do something like this online. I'm always on a system that's hardwired. So there's really no benefit. I kind of feel like it's selling people almost on a misleading metric because you're getting a great theoretical speed, but it's coming at a cost, and they're not always transparent as to what that cost is. Let's take a theoretical number at the 20 megahertz range, and don't hold me to this because I'm terrible at remembering like actual statistics for distance. Let's say 20 megahertz, you can see it great from 50 feet away going up to 40. That might drop it to 25 feet away going up to 80. You might get great signal at 10 feet away. On 160, you might have to be right on top of it. So again, I'd rather have a signal that's going to function over a longer range than something that's going to give me great speed if I've got the router sitting right between my legs, you know? And a lot of times
There's
too,
some
when they...
things you don't want.
Exactly. And a lot of times up here, like where they show max rate, you know, 1700, 1300, 1800, those are all such theoretical rates and not really representative of your actual connection. So even going back to Ed's example, where it was showing that he was connected at 144 megs, that's not really the throughput that he's going to necessarily see or get. That's just showing a best case scenario, theoretical number. And, you know, again, when they advertise those speeds, they're showing speed results from a lab environment where you're incredibly close to the connection. There's probably no other wireless noise in the area. So always take that with a grain of salt. And sometimes having a stable connection is better than a fast connection. Which leads me to probably my favorite thing. And this is one of the things that a lot of people don't really talk about, but it needs to be addressed. And that is something called buffer bloat. Now, there are some people in the networking world that kind of dismiss it. I am not one of those people. I am a firm believer in it, just like Bigfoot. This, to me, is probably the number one thing that you can address that's easy to address within your network if you have the right equipment, and will probably give you the most performance increase. So what is buffer bloat? Buffer bloat is a term for undesirable latency caused by your router or another network device from buffering too much data. This will cause suboptimal network performance, including packet loss. Packet loss occurs when one or more data packet on a network fails to reach its designation or its destination. This will negatively affect all applications like online gaming, streaming media, online meetings. Those are the areas that you're going to notice that the quickest. You also see it just in terms of general lag on the internet. I mean, you go to a page like CNN, you look on their back end, they've got 10,000 ads running, and those are constantly sending out little packets of data to ping back to their servers, to track everything you're doing, all of that stuff. And that's fine, but it has an overall net negative effect on your connection that you need to think about. But why buffer bloat and why now? Most standalone SOHO and networking devices basically function on something called FIFO, first in, first out. It's going to take the first request to send data out or to bring data in, and that's how it prioritizes traffic. It's not a very elegant system. It doesn't care about the size of the information that you're trying to move. It doesn't care whether you're just looking at a web page that's refreshing tracking cookies, or if you are on Dropbox syncing up files. It is going to handle the first data request, take care of it, and send it on its way before it moves on to the next one. So picture this like you're on the highway and 2 miles ahead of you, somebody slams on their brake because they aren't paying attention, and the ripple effect that that causes. Nothing bad really happened, but it was just one small event that caused this whole entire backup that leads to miles and miles and miles of traffic. The same thing happens on your home network. Again, web pages, they're constantly sending out little bits of data. If you're on a network with other family members, other devices that are streaming, even IoT devices, they may not be sending back huge amounts of data, but they are sending back packets of information, and that's causing a bottleneck of traffic. Again, it doesn't matter what the size is, it doesn't really care. It's waiting for one to finish transmitting before it moves on to the next. So this graphic explains it a little bit better. So if you look up here, this is your data. This is everything that you're trying to push through your router, push through your modem. It's going into a buffer. But your actual internet capacity is not that great. You're trying to push a huge amount of traffic from a big pipe into a small pipe. And that buffer on devices, especially cheapo routers and modems, it fills up very quickly. When that happens, pages will start to slow down. You'll get more latency. And when that buffer overflows, that's when you start experiencing packet loss. VoIP calls will become garbled. You'll start to see kind of that pixelation and slow down with Zoom calls. That's so infamous that everybody's going around. Then what do? We blame the ISP. We blame the network congestion that's going on, the outside world. But the reality is there's a lot that we could do just to fix that on our own end, which is where something like managing your own traffic comes in. You need to have some sort of traffic manager or flow control set up that helps kind of buffer that and takes that huge stream of data and releases it in a more intelligent, queued manner to prevent your system from becoming overflowed. And the result is you can end up passing a lot more traffic. You can have better net results by implementing a system like that. So these are some real world speed test examples that Ed sent to me. As you can see, some of these people have phenomenal speed. 403 megs down, That's incredible. This guy has 716 megs up. That's a ridiculously fast speed. But if you look at their buffer bloat score, F, C, D, without knowing these people, I can almost guarantee that they've experienced some issues on their networks when they're doing things that are a little bit more network intensive, like being on a Zoom call, streaming things where they're having kind of that quality issue. And what's like the number one ISP, you know, you call it solution, you call them up, I'm having problems with my connections. What do? They try to sell you on a new piece of hardware, or they try to sell you on a faster package. But the reality is, it's still just trying to push too much through an improperly set up or improper hardware to begin with. This is another great example for somebody that wants to look nerdy or get a little bit nerdy. This is somebody that was pinging a server. As soon as they started to upload a file to Dropbox, you can see right here, their response time took a huge jump. It went from under 20 milliseconds to 170 milliseconds. And then you can see subsequently, it goes all over the place. And it's jumping up, it's jumping down. You see these huge spikes right here. You see this where it says request timeout. That's an actual packet being dropped. So if you're transferring a file, you're having a call, that's going to be an element of jitter or of static or an improper file transfer. So this is not what you want to see. I'm sorry that I keep doing that. You don't want to see something like this. How do you know if you have buffer bloat? I can almost guarantee you already have it, whether you realize it or not. You don't have to take my word for it. DSL reports, they have, within their speed test, they have a specific metric that measures for buffer bloat. If you go to www.dslreports.com/speedtest and test your speed, most people will probably have a pretty bad score. This was my own personal case of mild buffer bloat. I disabled, in this first graphic here, I disabled some of the rules that I had set up personally on my network, and got a score of B. It's not terrible. It's not great though. It's not the optimized connection that I want to have. This second one involved me going back in, re-enabling some of the queuing rules that I had, but also decreasing the overall amount of bandwidth that I allowed myself to have. Straight from the ISP, I'm getting 120 megs, 25 megs up and down. This is me dialing back the connection to 90% of that. This last one here is with the same queuing rules that I created for my router, but also dialing my overall bandwidth that's available down to 80% of my overall speed. And you can see that my buffer bloat score shot up to an A+, which is awesome. And I'm completely happy with that. When I run my connection like that, I very rarely experience any problems, any jitter. My ping times, if I'm uploading or pulling down files, stays extremely stable. If I'm on a hardwired connection doing a call like this, I rarely have any dropout or any loss of quality. It still happens, but by tweaking it, I've really minimized the number of times that it actually does happen. So what can you do to get rid of buffer bloat? The best thing to do is to enable smart queue management on your router. This refers to a couple different protocols. There's one called FQCODL. There's another one called Cake. And basically what it does is it allows your router to manage the packets going in and out a lot more efficiently. If you don't have a piece of hardware that has SQM, look for something called QoS, or quality of service. QoS can take a little bit more tweaking sometimes to find the best settings, but it's the next best thing as opposed to smart queue management. The second thing that you could do is to limit your overall bandwidth. You never want to fully saturate your overall amount of bandwidth, because if you need that little bit of burst, or if your router decides it needs a little bit of burst because you have a lot going on, you've given yourself no overhead. So you're just creating an additional bottleneck in your connection. If you cannot do either of those things, which, by the way, if you can limit your bandwidth but you don't have SQM available, you could do that and you will still see an improvement. However, if you cannot do those things and you have a horrible buffer bloat score, you should really look into revamping your network hardware. There's a couple of really, really great brands out there that makes hardware that's relatively inexpensive. A company like Ubiquiti, they have two lines that are really great. They're EdgeMax and Unify line. They give you great control over SQM and FQCODL. They have a great user base online, and they're a little bit more user-friendly, especially a line like Unify. It's something that can be a little bit easier for the average person to set up. There's another brand called MikroTik. They make ridiculously amazing products. There's a ton of control that you have. They tend to be a little less user-friendly to set up. I personally use a MikroTik. Once you get it set up initially, I haven't touched mine, gosh, in ages. I haven't had an issue with it. They're amazing, but they can take a little bit more work to set up. Another option would be to explore a project like OpenWRT. This is, I don't know how many of you remember like the old Linksys WRT 54Gs, the little blue and black ones with the antennas on the back. You used to be able to put third-party firmware on that called DDWRT, which gave you an expanded feature set. There's a new version of that that's a little bit more mature called OpenWRT. It's open source software. You can run it off of a ton of different routers, the Netgear R7800, and then a couple different Linksys models. There's a ton of different ones you can run that off of. If you reflash that firmware with OpenWRT, you kind of unlock that whole feature set. You still have to be a little bit cognizant of making sure you're tweaking the right settings to make sure you're getting the best performance out of those. But you're able to unlock a huge feature set like that, which is great. There's also a new product out. I think it's been out for about 2 years. It's called the IQ router, which simplifies some of that setup. I haven't tested one yet. I'm trying to get my hands on one, which hopefully I will pretty soon. They offer kind of an out-of-the-box remedy to buffer bloat and to optimizing your connection, where you don't really have to do a lot of setup. It happens on the back end. So that may be worth something checking out. And a lot of these systems here, they're relatively inexpensive. You can get Ubiquiti or MikroTik routers that will perform amazingly well with built-in wireless capability on the MikroTiks for under $100. I mean, the router that I use from them, it cost me, I think, $45 online. And the wireless signal lights up my entire apartment, 1,700 square feet. So great performance. Again, even with OpenWRT, some of those routers out of the box cost like $170 to $200. The software itself is free. But to me, it's a great trade-off, especially if you're going to get a really increased performance out of it. The IQ router sells for, I think, $220 off of Amazon, or you can buy it directly from them right now. And I think that's all that I have on that.